Arcane Factoids with Sam the Professor Wilson.
Hey there, Fingerpistol friends. In these days of modern times, with our nation facing a period of unprecedented challenge, we're all looking to stories of our shared commonalities to make us feel a little less alone. Tonight's Arcane Factoid touches on these themes. 1, things we all share in common, and 2, that you're never really alone. And I want to start out with a riddle. What do the lovely and talented Fingerpistol girl singer Meg Bodie, actor Tony Shalhoub, U.S. Secretary of Education Betsy DeVos, astronaut Buzz Aldrin, and you, dear viewer, all have in common? Face mites. Face mites are microscopic, translucent, vermiform arachnoids. They're relatives of spiders, scorpions, and ticks. At 1/100th of an inch in length, they're the smallest of all the arthropods. They have 4 pairs of tiny legs on each side of the first third of their worm-like bodies, and they can and do walk on your face, albeit very slowly. It would take over 12 hours for a face mite to run the marathon from your nose to your ear. Now, we're not born with face mites, but virtually all of us will acquire them by the time we reach our 20s. And once they've moved in, they don't leave. The older we are, the more likely we are to have face mites. We tend to have higher mite populations when we're in our greasy-faced teens because mites love skin oils. They can live on other parts of the body, but they prefer our faces because they're the oiliest. Although we don't need face mites, they absolutely need us. They can't live anywhere else, survive anywhere except in human follicles or sebaceous glands. Other animals have their own species of parasitic mites, like the ones that dogs get that lead to mange, but our mites have evolved to live only on humans. Face mites aren't really a problem for most of us. They're generally harmless. They spend their daylight hours motionless, head down, kind of like an ostrich, buried up to their necks in the follicles of our velum hair. And the velum hair is peach fuzz. It's that tiny little hair that we all have. When they're there, they sleep and they eat our sebum through these needle-sharp, really vicious-looking mouth parts that they also use to puncture our epithelial cells and drink the cell contents. They freeze, and I don't mean freeze like freeze, but they stop moving whenever they're exposed to light. But when the lights go out, woohoo! There's a mighty sex party on your face. Since male face mites outnumber female face mites about 4 to 1, there's probably quite a few male incel mites out there. After mating, the female lays an egg in a hair follicle, which is quite a feat considering that a face mite egg is 1/3 the size of the adult face mite. That'd be like giving birth to a 50-pound baby. The eggs hatch after 5 days into 6-legged nymphs, which I thought was interesting, grow into 8-legged adults in a couple of days, and then they live and hang out on your face for about another week before dying. The whole face mite life cycle lasts only 2 weeks from hatching until death, which means that each of us has likely nurtured hundreds of generations of face mites. An interesting factoid about face mites is they don't poop, and they couldn't poop even if they wanted to because they don't have an anus. They just keep filling up and filling up with mighty poop until they die, and then they rupture, spilling their poopy contents into your follicles. It's thought that face mite poop could contribute to rosacea and acne because face mite numbers are much higher on folks with rosacea and acne. Keeping in mind that correlation is not causation, the fact that these dermal conditions do respond well to antibiotics strongly suggests that the bacteria that are released when the dead face mites rupture or pop and all that mighty poop gets popped onto your face, that could contribute to your occasional less than perfect skin. Humans and our face mites have evolved together for at least tens of thousands of years. And just as humans have evolved different physiognomies based on the region in which we develop, the face mite genome also shows distinct regional variants. Asian face mites are genetically different from South American face mites. What's so cool about that is that we can gather significant insight into the human diaspora by examining genetic drift in face mite DNA. And they're in the process of doing that now, scientists are, and they think they've discovered a few interesting things about our Out of Africa movement. And now my final mighty factoid. Remember my earlier allusion to Buzz Aldrin? Other than humans, face mites are the only complex multicellular organism ever to have gone to the moon and back. So thanks. Good night, everyone.
Arcane Factoids with Sam the Professor Wilson.